Today we're modeling a very fancy bathroom faucet. This is a complete beginner-friendly tutorial. If you want to practice modeling a very expensive Dornbrock Terra single-hole lavatory mixer at real-world scale from nothing but a spec sheet, then hold on to your butts because this video is for you. First, do a Google search for the product and find a downloadable product spec sheet. I'm not going to leave a link in the description for this. If you're trying to learn Blender seriously, you should be able to summon the technological fortitude to find it on your own amongst the vast interwebs. If you really can't find it, leave a comment asking nicely and I'll send it to you. Sometimes if you're lucky, brands like Kohler will make it easy for you, and in addition to the product spec sheet, they also provide a vast array of design files in both 2D and 3D formats. In my experience, I've found that OBJ works well for Blender, as well as Rhino if you or someone you work with uses that. Save the spec sheet for your records, but screenshot and save the dimensioned line drawings as a texture. Do not keep the default screenshot file name. That usually starts with like a 14-digit date sequence. You should name it something appropriate, like the name of the thing that you're making. This image will be the reference drawing that we'll model from. Import the drawing as a mesh plane or use the Import Images as Planes add-on for older versions of Blender, and then rotate it accordingly. I'm rotating it to face the front view because the drawings are of the front view and the side view. To model at accurate scale, I personally usually start with a reference object. The idea is to scale the drawing plane to accurately match a known dimension. I'll add a cube and make it 180 millimeters wide. That's going to be the red X direction, by 275 millimeters tall. That's going to be the blue Z direction. I want this to match the overall width and height shown in the drawing. This is a pretty cool feature. Even though my units are in inches, I can type these values in millimeters as the dimensions, and then it converts it automatically. Thanks, Blender. I like to create a wireframe of the reference object by going to Object Properties, Viewport Display, Display As, and changing Textured to Wire. They don't teach this in school or in an office, but this is just something that I do to help position and scale the drawing to match the reference object. It doesn't have to be perfect, but it should be close enough. I'll align the bottom corner of the reference object with the bottom edge of the 275 millimeter dimension line, and place the 3D cursor on that corner by box selecting those vertices and pressing Shift S2. Shift S brings up the cursor wheel, and 2 chooses cursor to selected. That's a lot to say, but it's a quick, useful shortcut that grabs the cursor and then centers it on whatever you have selected. That will work in both object mode and edit mode. I know that this box is 275 millimeters tall, and I want the drawing dimension that says 275 to match that height, so I need to scale it to match, using the cursor location as the base point. In order to transform about the 3D cursor, I need to access the Transform Pivot Point menu. Normally, you can access this menu at the top of the 3D viewport next to the snaps, but I use this menu so much that I've created a custom shortcut to access it wherever my mouse happens to be. When I press Shift and the numpad 3, which for me is the top row of numbers because I've enabled Emulate Numpad in the settings, I can change the Transform Pivot Point to the 3D cursor just by pressing D, which you can see is underlined. Now I can scale the drawing plane so that the dimension line, which says 275 millimeters, matches the reference object height, which I know is 275 millimeters. Let's take a second to look at how Blender menus work. To quickly select commands from a list just using the keystroke, there's usually an underlined letter on each choice to quickly select that command, or it's a number on the wheel selection menus. That can be very helpful with shortcuts. I try to keep a lot of my shortcuts all right here on the left side of the keyboard, so I don't have to significantly change the position of my hand on the keyboard often. So from this hand position, Shift 3 now brings up the Transform Pivot Point menu, and the common shortcuts that I use here often are B for bounding box and D for 3D cursor. I also use individual origins a lot, but I'm not going to move my hand all the way over. So I usually just move the mouse down slightly. Shift S brings up the cursor menu, and 2 is right there as a very quick option to place the cursor to selected. And you can also pick any selection just with a small mouse gesture. Also set up my shortcuts so that when you tab into edit mode, Alt 1, Alt 2, and Alt 3 switch between vertex, edge, and face selection mode. Normally it's just 1, 2, and 3, but I have Emulate Numpad enabled, so my top row of numbers acts like my numpad. So numpad 1 and 3 are reserved for front view and right view. Again, I set up this habit originally out of necessity when I learned Blender on a laptop that didn't have a numpad, but now this laptop has a numpad, and I still wouldn't move my hand all the way across the keyboard just to access the numpad. The period button also brings up the pivot point options in a wheel menu, but again, it's all the way over on the right side of the keyboard. and I find that to be really disruptive to me and my workflow. It's a small difference going from one side of the keyboard to the other, but you're doing these actions thousands of times a day, and that time adds up. And this isn't a shortcuts video, but there are a lot more examples. I've set up local view, which isolates an object to be Alt-Q. Normally that would be the slash button, but you guessed it, it's all the way over here, and I'm not going to do it.
What do you mean you're not gonna do it?
Not gonna do it.
You are too gonna do it.
Not gonna do it.
You are gonna do it.
Alt-Q also allows you to switch between objects in edit mode. Shift-Z toggles between wireframe and solid or textured modes. Control-Tab brings up the mode selection wheel. And Shift-tilde activates the walk command. There are a bunch of useful ones all located here on the left side of the keyboard. Interesting story about Starbucks. They run simulations on different coffee bar layouts. They call them engines, and they test out different placements and combinations of sinks and ice stations and grinders and coffee makers and stuff like that. And then they compare the time difference it takes to make a variety of drinks. Engine 1 may make an iced coffee 5 seconds faster than Engine 2, but over the course of a day or a year, the difference gets multiplied thousands of times. And that extra time builds up and could be used to be making more drinks, which of course makes more money. Time equals money. So learn your shortcuts. You want as little resistance as possible between thinking something and executing it and doing it. And knowing your shortcuts and even setting custom shortcuts is what helps me reduce the friction between a thought and a reality. To me, that's what a lot of design is. Freely expressing your ideas and testing them out. When you're working and collaborating with people on a design, you don't want to be focused on remembering shortcuts and commands. When I was a younger designer, I used to hate when someone would stand over my shoulder and just watch me work, because they expect you to be able to do something very quickly. But anyone who does 3D modeling knows that sometimes those things take time, and being put on the spot like that is not a great feeling. But as I got older and obviously faster, those working sessions around a live model, which you can update in real time, became super useful in design meetings. Being able to visualize and try out design choices in real time on the fly in a 3D model is a super useful skill to have. Anyways, I think this is one of the tougher parts of modeling correctly at scale. Once everything's the right size, modeling is the fun and easy part. I'll start with a cylinder for this central pipe and use simple commands to match the drawing. S to scale down to approximately the right size. Shift Z to toggle into wireframe mode from solid shading. Box select the bottom face. G to grab or move. Z to lock movement in the Z direction, and hold down Shift to fine tune the placement. In face select mode, duplicate the bottom face with Shift D. Right click to reset the position. S to scale it up, and E to extrude downward to create this base plate. Again, using Shift Z to toggle into wireframe mode. Box select the top face of the cylinder, I to inset that face, and E to extrude upwards. Control and the plus button will increase your selection size, and now we need to increase the diameter of this pipe. Press S to scale and Shift Z to scale in all directions except the Z direction. See how the pipe is getting fatter without getting taller. That's scaling uniformly in the X and Y directions, but not scaling in the Z direction. Select the top face and press GZ to pull it upwards towards the beginning of the curve in the pipe. I'll create a linked duplicate over to the side to create the semicircular portion of the pipe. We're going to use the spin command, which can be found in the extrude menu. The spin command will create a circular extrusion centered about the 3D cursor. So we want the 3D cursor to be located in the center of this circle, which we know has a 135mm diameter. I could quickly approximate this by pressing Shift right-click on the mouse to visually place the cursor, but that won't be very accurate. Instead, I'll select the top face and place the 3D cursor there with Shift S, then 2. Remember, that's the quick shortcut to access the cursor menu and then choose Cursor to Selection, and then add an empty object there. I need to move it over 67.5mm, which is the radius of the circle, or half of 135mm. G to grab, X to lock movement in the X direction, and I wish you could type 67.5mm to move it over that amount, but in this case, since my file is set up using inches, I have to convert that and then type it in as inches. It would be pretty convenient to be able to do that, like with the dimensions in the N menu, where you can type in a value in millimeters or inches, but for the move command, you have to type the value in your scene units, which again for me is inches. So this is the location of the center of the circular pipe. I want to place the 3D cursor here for when I do the spin command. Select the empty, Shift S2, and now the 3D cursor is located in the center of the circle. Select the leading face of the pipe and press Alt-E to bring up the extrude menu. And you can pick the spin command by pressing S, again because you can see the S in spin is underlined. So now this top face has been extruded in a circle about the 3D cursor. The default is a full circle or 360 degrees, so we want to reduce that to 180 degrees because we only want half a circle, and then increase the step count for a smoother pipe. Box select the top of the pipe and then GZ to pull it up to match the drawing. Select the leading face and continue to extrude it downward, and then model the larger end of the spout by duplicating the face with Shift D, right-click to reset position, S to scale it up slightly, and then E to extrude it downward. I to inset that face, and then E to extrude it upward to make it appear like it's a hollow pipe. So now the main central pipe is modeled, and I can rotate the original back to face forwards. The last thing to model are these angled handles. Big picture, I'm going to model it on one side, standing straight up without an angle, add a mirror modifier, and then rotate it in object mode. So add a new cylinder, S to scale down to approximately the right size. Grab the top face, I to inset, E to extrude, I to inset again, and E to extrude again. Shift D to duplicate this top face, right-click to reset position, RX90 to rotate 90 degrees about the X-axis, E to extrude the circular face to create a cylinder, and then extrude the other side an equal distance. Press Ctrl L to use Select Link All to select this entire cylinder. Shift D to duplicate it, right-click to reset position, and then RZ90 to rotate it 90 degrees about the vertical Z-axis. Add a mirror modifier and use the eyedropper to select the main pipe as the mirror object. We want the axis of reflection to be the Y-axis. Now in front view, I can rotate this handle to align with the reference drawing. If I need to make any adjustments, for instance, if I wanted to make these handles longer and taller, I can create a linked duplicate off to the side with Alt-D, and then clear the rotation value with Alt-R. That's why we rotated this in object mode. It has a rotation transform value in the end menu. If we did this rotation in edit mode, the handle would look correct, it would be rotated, but the object would have no rotation transform. It's a small difference to distinguish, but it can have an effect. But now in edit mode of the linked duplicate, I can raise the top of the handle up by pressing G to grab and then Z for the Z direction, and increase the length of the handles by pressing S to scale and then X for the X direction, and then copying it and rotating it again. Since they're linked duplicates, you can see the angled version will update as well. It's typically easier to model along global axes, the X, Y, and Z axes. You can adjust rotated models using local axes, but it's a little bit more difficult. For instance, in edit mode of the rotated handle, if I wanted to lengthen this handle, instead of pressing G to grab and then Z for the Z axis, which will raise it in the global Z direction straight up, I have to press Z twice in order to access the local Z axis. Global Z is directly straight up and down. Local Z for this object is at an angle. So now that the handles match the drawing, you can apply the mirror modifier by pressing Ctrl A to bring up the Apply menu and selecting Visual Geometry to Mesh. You can also apply the modifier from the Modifier tab, but I think Visual Geometry to Mesh is faster, and sometimes when you're applying multiple modifiers in a stack, the order in which you apply them can affect the appearance. Once that's applied, you can select the central pipe and press Ctrl J to join it into one object. And that's all the modeling required for this fixture. Create a new material under Material Properties, call it Chrome, increase the metallic, and decrease the roughness to make a polished metal surface. Check the scale factor is 111. Add a small bevel modifier and you're done. Press M to bring up the Move to Collection menu, create a new collection and call it Dornbrock Lavatory Mixer. And if you want, you can mark it as an asset and add it to your asset library for future use. So this isn't going to be a portfolio piece, but hopefully it's been good practice if you're new to modeling. We covered a lot in this short tutorial. Importing and scaling reference drawings, modeling using simple commands like move, rotate, inset, extrude, as well as more complex commands like the circular extrusion using the spin command and mirror modifiers. If you enjoyed this content, don't forget to like and subscribe, and let me know in the comments if you have any questions or requests. I'm Andrew, and this is My 3D POV, and thank you for watching.